We will now determine the value of k such that the function g of x is continuous. So we utilize the definition of continuity. That is, a function f of x is continuous at x equals a if and only if the limit of f of x approaches a equals f of a. So that is, the limit of the function should equal the value of the function at x equals a. So let's apply this continuity definition to this g of x function. We know that the g of x is continuous everywhere. So it must be continuous at x equal to 4 as well. So when we apply the definition of the limit to the g of x function, we write down this as a limit of g of x when x approaches 4. This should equal the value of the function at x equal to 4. So we write down this as g of 4. And since x approaches 4 over here, this means x is closer to 4 but not 4. So we can say that x is not equal to 4. And this means we utilize the first expression to evaluate the limit. So I'm going to replace g of x using the first expression, that is 2x squared minus 5x minus 12 over x minus 4, x approaches 4, and this equals g of 4. For g of 4, we will utilize the second expression because at x equal to 4, it is given by this expression. So basically, we replace this expression and replace x by 4, and that becomes k times of 4 minus of 5. Now let's evaluate the limit on the left side. So basically, we can do the direct substitution here to check if we get a definite value of the limit. So when I do the direct substitution when x approaches 4, this becomes 2 times of 4 squared is 16. So this becomes 2 times of 16 minus 5 times of 4 minus 12 divided by 4 minus 4. And this gives 2 times 16 is 32 minus 5 times 4 is 20 minus 12 divided by 4 minus 4 equals 0. Negative 20, negative 12 is negative 32. Negative 32 plus 32 is 0. So basically, we get indeterminate form, which means we have to adopt some other techniques. Maybe we can utilize the factoring technique. So let's factor the numerator expression. So when we factor the numerator expression, that is this 2x squared minus 5x minus 12, we will get this expression, that is 2x plus 3 times of x minus 4 over x minus 4. And on the right side, we can write down this as 4k minus 5. So clearly, we can see that we can cancel this x minus 4 with the x minus 4 in the numerator. And finally, this limit becomes limit of x approaches 4 to x plus 3. And this equals 4k minus 5. Now we can once again do the direct substitution to evaluate this limit. So when you do the direct substitution, we get 2 times of 4 plus 3. This equals 4k minus 5. 2 times of 4 is 8. 8 plus 3 is 11. So on the left side, we have 11. This equals 4k minus 5. Now we add 5 on both sides. So which means 11 plus 5 is 16. We get 4k on the right side. So when we divide by 4 on both sides, we get the value of k equals 16 over 4 is 4. So this is the value of k.